Salt is one of the most common things in your kitchen. You sprinkle it on fries, mix it into soups, or add a pinch while cooking, but long before it became a simple seasoning, salt was one of the most powerful tools humans had. In fact, salt was once so valuable that entire civilizations traded it like gold. Why? Because salt could do something incredible. It could stop food from rotting. Without refrigerators or freezers, salt allowed people to store meat and fish for months. Sometimes even years. But how can a simple white crystal slow down decay? What actually happens at the molecular level when salt touches food? Today, we're exploring the science of food curing, from ancient preservation methods to modern industrial technology, and along the way, we'll discover how salt is still shaping our future in ways you probably never imagined. How salt actually preserves food. To understand curing, we need to start with the basic science. When fresh meat is left out in the open, bacteria quickly begin to grow. These tiny microorganisms feed on the nutrients inside the meat. As they multiply, the food begins to spoil. Salt stops this process in a very simple but powerful way. Salt pulls water out of the meat. This process is called osmosis. Without enough water, bacteria cannot survive or multiply. At the same time, salt changes the structure of proteins inside the meat. Scientists call this protein denaturation. The proteins tighten and bind together, giving cured meat its firm texture and deep flavor. That's why cured foods like ham, bacon, and salami taste so different from fresh meat. The traditional craft of dry curing. For thousands of years, people preserved meat using a method called dry curing. This process is slow and careful. Salt is rubbed directly onto the surface of the meat, then the meat is placed in a cool, controlled environment. Over time, the salt slowly travels into the meat while drawing moisture out. This process can take weeks or even months. During that time, natural enzymes inside the meat begin breaking down proteins and fats. These chemical reactions create the deep, complex flavors that dry-cured meats are famous for. Think about foods like traditional country ham or aged prosciutto. These products are not rushed. They are slowly transformed by time, salt, and chemistry. Dry curing is as much an art as it is a science. Modern industrial brine injection. While traditional curing takes months, modern food production often moves much faster. Today, many meat processors use a technique called brine injection. Instead of waiting for salt to slowly travel through the meat, machines inject a liquid solution directly into it. This liquid is called brine. It usually contains water, salt, sugar, and curing agents. Special needles pump the brine deep into the meat within seconds. After that, the meat is tumbled in large rotating drums to spread the liquid evenly. What once took weeks can now happen in just hours. This method helps large companies produce massive amounts of bacon, ham, and deli meats quickly and consistently. It also keeps the meat juicy while preserving flavor and safety. Why nitrates and nitrites matter. Another important part of curing involves chemicals called nitrates and nitrites. These compounds play a critical role in food safety. They stop the growth of dangerous bacteria, including the one that causes botulism, a rare but extremely deadly illness. Nitrites also give cured meats their familiar pink color. Without them, cured meats would turn a dull gray. Because these chemicals are powerful, their use is carefully regulated. Modern food safety standards strictly control how much nitrate or nitrite can be used. By 2026, food safety guidelines have become even more precise, ensuring that cured foods stay both safe and visually appealing while minimizing health risks. The rise of natural bio-curing. In recent years, consumers have started asking for foods with fewer artificial additives. This demand has created a new movement called bio-curing. Instead of adding synthetic nitrites, manufacturers use natural plant extracts. One of the most common sources is celery. Celery naturally contains nitrates. When combined with special bacteria cultures, these nitrates convert into nitrites during processing. The result? The same protection against bacteria, but with ingredients that sound more natural on the label. Many uncured meats you see in grocery stores today are actually produced using this natural curing process. It's a modern blend of science, biology, and consumer demand. The future of sodium in a high-tech world. Salt isn't only important in food, in fact, it plays a massive role in modern technology and industry. Salt is one of the most widely used raw materials on Earth. Every winter, millions of tons of salt are spread on roads to melt ice, but modern technology is improving even that process. New smart de-icing systems can measure road temperature, humidity, and weather conditions. These systems release just the right amount of salt at the right time, reducing waste and protecting the environment. Salt is also critical in chemical manufacturing. It is used to produce chlorine, caustic soda, plastics, paper, and countless everyday products. In many ways, salt quietly supports the foundation of modern civilization. The health paradox of salt. But salt also comes with a complicated challenge. While humans once depended on salt for survival, today many people consume too much of it. High sodium intake is strongly linked to high blood pressure and heart disease. This creates a modern paradox. The same mineral that once preserved our food and protected our health is now something doctors tell us to limit. Because of this, food scientists are searching for ways to reduce sodium in processed foods while still keeping flavor and preservation. It's a delicate balance between taste, safety, and health. The health paradox of salt. But salt also comes with a complicated challenge. While humans once depended on salt for survival, today many people consume too much of it. High sodium intake is strongly linked to high blood pressure and heart disease. This creates a modern paradox. The same mineral that once preserved our food and protected our health is now something doctors tell us to limit. Because of this, food scientists are searching for ways to reduce sodium in processed foods while still keeping flavor and preservation. It's a delicate balance between taste, safety, and health. Sodium and the future of energy. Surprisingly, salt may also help power the future. Scientists are currently developing sodium-ion batteries. Most modern batteries use lithium, which is expensive and difficult to mine. Sodium, however, is incredibly abundant. In fact, it's one of the most common elements on Earth. Sodium-ion batteries could become a cheaper and more sustainable option for storing renewable energy. By the year 2030, many experts believe sodium batteries could help stabilize power grids that rely on solar and wind energy. If that happens, salt may become one of the key materials driving the global transition to clean energy.